Hello. So last time we fixed up the die macro to not use stir error because this was considered to be thread unsafe. And now I've just remembered that I still have stir error around in a few other places in the code, so I'm going to go ahead and fix that now. And one place is, well, two places is in here, check kanji DB order, which is used to verify the validity of the kanji database and compare it against Unicode data and make sure that our ordering makes sense. So I'm going to just change this to use the die macro now, and I'll say 1 to include the error number, and then the error message will indicate that we died reading a certain line. And that's all we got to do. That's pretty easy. And here we'll do something similar. This is so this is die show error number reading line, and this is happens when we're scanf-ing cur. So I'll just have cur. Oh, but I think cur is cur really long? Cur is just gonna have the line is only gonna be the line itself. So here, cur is only gonna span the current line. It's not gonna be like the whole file or the whole buffer. So uh, I'll just include the entire line in the error message. That seems a little more intuitive. Okay. Now let's look for stir error again, and now it's only in util.c. Stir error. Okay, here and here. So, okay, we're going to say that there's an error when running pf open. So this is essentially just going to be running. This is just going to involve running p error. And over here, it's going to be the same deal. So p error, I believe, allows you to just pass a prefix or a preamble here to give information about the error. So we're just going to change these to stir error. So let's just replace these stir errors with p error, because that seems to be something very straightforward to do. It doesn't let us include this path name here. So let's see here. How are we going to handle that? Because we can't actually include a path name easily. Report fopen failure. Now, why is this not fatal? Git grep report fopen. Because it seems like it would be easier if this were just always fatal. Report fopen failure. This happens in testutil and also in this file fopen. Okay. Let's see. Void util.c and in testutil. Report fopen failure. Exp opened. Oh, and this is not very good because this uses. Yeah, this doesn't have things in the right order, it seems. Let's move this because we're checking for an error in exp opening, not act opening. Oh, and I actually want to fix this. There's no reason to buffer the input from this C file stream. There's no reason to do that because apparently this is already buffered. So so let's see how to handle this. XF open. Well, that's orthogonal to the current goal of fixing stir error and not using stir error. So we could just write in. We could just do this p error expected file name. Report F open failure. Yeah, I don't know. Because then we don't include the fact that it happened when we were opening the file. But maybe that's fine because it's the error is probably going to be very obviously having to do with opening the file. Um, Here, let's go to util.c. Here, I have an idea. So we'll say, so we will do this to say p error. We'll just hard code the whole string here. Okay, there. And then we want to go ahead and say fprintf or xfprintf the file name. Error or standard error, I guess. Um, File name. File name. Okay. There. We don't need a new line anymore. Okay. Grep stir error. There shouldn't be no more uses of stir error. Oh, there is one. This is a this is just a straightforward conversion to use p error. Okay. There we go. If not, f close stream. Okay. Then we go. Let's go to input dots or test util and fix that ordering problem. Expected. We'll just leave that for now. Okay. And so we did these. These are straightforward usages of die, and we also changes to use p error. And good, we don't have it. We don't have the new line there anymore, but we have it here. And this. Okay. So that looks good. So let's make this, and everything passes. So we'll commit this and say that we'll say remove remaining uses of stir error. Okay. Now the other thing I want to fix, because the next change I'm going to do has a lot to do with this, is I want to stop using this this buffer because this is just redundant with the C file streams apparently. So then, so we don't need IO buffer at all. Let's just delete that. And here, instead of using IO buffer, we don't need IO buffer read, and we don't need IO buffer has more. So we're just going to inline just about everything. Change, and then we'll do file. Oops. File. Okay. File. And okay, we don't need the brackets here. Oops. And we'll put X last. Okay. X open equals not X. Okay. Good. So now we will do buffer has more and IO buffer has more. Okay. So let's see here. Going down to failure and exit. Okay, Okay, so as soon as we see that the output is different, then we're going to exit. So let's see. We'll just make this into an infinite loop, or a while loop without a normal condition. Then we are going to compare exp and act. So xf get c. I think we have a get c. Yes, we do. Xf get c. Exp. So we'll do int x c equals this. And we'll do actual c equals f xf get c actual, and we'll have to. By the way, we're comparing test output with expected output right here. And what we'll do is now xf get c will return -1 on error. Let's make sure that's true. Not on error, but on end of file. So if it's not an error, yeah. So if it's in, we want to report that there's a bug. If there's already an error in the stream before we call xf fgetc, and then we use ferror to check if there was an error. So this should return EOF, which I think is -1. So man fgetc EOF on end of file or error. Okay. So if xc is not equal to axc, then we have a failure. Go to failure. And this will compare both characters as well as compare the length of the file implicitly, since we're comparing end of file here. So great. Now if xc is EOF, then we can break. And that means that we succeeded. Okay. And now we don't need this. And then we should be done. Make act. All right. Good. Now, by the way, this error that it just reported. Act as a pointer. Did you mean to use dash? Yeah, I wonder if I can actually access the members of EXP and ACT. I'm kind of assuming that the C library just encapsulates this so that I don't have access to the members, which is possible as long as you don't give the content of the struct in the header file. But anyway, let's commit this. We'll say remove unnecessary let's see, IO buffer class or utility code or struct there. Okay. And all right. So next is some actual fun stuff. I'm going to make it so that we do this file reading in a separate thread. And the reason I'm going to do that is because we want to process. Let me be more specific. So we have actual test output and expected test output, and the actual test output is written to a file. When we start a test, we redirect output to let's see here, start test. We redirect standard output and standard error to the actual file, and then we compare it. So the problem with this is that we don't actually care about the raw output. We kind of want to actually ignore null bytes, because if you remember, keyboard.c includes null bytes when it's printing out this keyboard in some cases. So we want to kind of adjust the output so that we do not include null bytes, and that way we can use diff and merge and stuff easily with the expected test output, and it'll work with all text editors. And So in order to do that, we essentially have to intercept this output before it gets to the file. That's one choice. Or we and so the two options are one to intercept the output as it's getting sent to the file, or two to rewrite the file after it's already been written, and then at that point remove all the null bytes or do any kind of other cooking of the data so that it's easier to compare. And I'm choosing to go with the intercepting route because this is seems more natural to write the code for it, and not necessarily for performance or anything like that. Since copying a file is really nothing to worry about. Although copying several files, for if there ever end up being hundreds of tests, maybe that will become kind of bad once we're copying hundreds of files and rewriting hundreds of files. But in any case, the main motivator is to and choosing that route is to make the code a little bit more natural, and also because I'm interested in using in writing like some threading code, it just seems a little bit more fun. And so that's what's going to happen next. And let's see. So how are we going to do this? So we need to have a few variables which tell which tell this extra thread how to work, and there's only going to be one extra thread at a time. So we can just make these global variables. So in start test down here, instead of just opening a file, what we'll do is we'll make a pipe, and then we will store information about the pipe and the file to write the test output to in some static variables or global variables. So let's see. We already have global variables for some of these things, like actual fn, and test source file is not going to be important for this thread, but actual fn is, and the file, the like pipe, is also going to be important. So we will do I guess static file, let's see, test output stream, test output output pipe read for the read end of the test output pipe. And then I'm pretty sure that so we're going to get a pipe with the pipe system call, pipe postfix, or is it, here we go. So we're going to get a pipe with this, and we'll then once we have this pipe, we're going to wrap it with there's some other function like open, what was it? There's a function to wrap a pipe as a system file handle into a C file stream. I don't quite remember what it is at this point, but maybe it was drawing a blank. It was, let's see, open a, or about wrap a system file handle in a C stream. Here. And this was available in Mac. When I researched this function, it was available in Mac OS and Linux, and there was even a Windows equivalent, which operated with Windows file system, Windows operating system file handles. ftstream. Oh, so the thing is, this is talking about C++ fstream, which is not what what we want using creating pipes in C. AC. In AC. File. F open. It was, let's see here, system call Linux. How about open? Let's say open POSIX pipe as C stream. Read from pipe. FD it was FD open and FD open here. So we'll use this to wrap the pipe file descriptor, and yeah, that we'll use it to wrap both ends of it and then close it later. And I think that this will tell you that if you close the file stream in C, it will you close this file pointer, then it will automatically close the underlying thing. So fd open errors attributes. Let's look for close. It will be closed when the stream created by fdopen is closed. The result of applying fdopen to a shared memory object is undefined. This is in the context of, let's read the whole paragraph. The fdopen function associates stream with the existing file descriptor fd. The mode of the stream must be compatible with the mode of the file descriptor. The file position indicator of the new stream is set to that belonging to fd. And the error and init file indicators are cleared. Modes W or W plus do not cause truncation of the file. The file descriptor is not duped and will be closed when the stream created by fdopen is closed. Okay. So let's see here. Now we don't need we already have a file for we already store the file for the right end of the stream in the out and error global variables, which are, for example, here, right here. So in start test, we're going to create a new thread, actual fn. I wonder if I need to move these variables around because this one is pretty far away from where it's used. So we need to include threads. So what was it? P threads, POSIX threads, P thread. Create. I think there's a create, P thread create. Okay, man3 P thread create. So P thread.h. And then this is a pthread t, so static pthread t thread. We'll call this test output processor. Test output processor. And thread that takes test output and removes binary looking bytes. Okay. Test output processor. Now go to start test, and we have here test output processor equals, it's pthread create, and the return value success return 0 once the thread are undefined. No. It doesn't say if it sets error number. Handle error and pthread. According to this, it implicitly says that it does, because here it's handling an error, so we can do that too. error no equals n, p error message exit failure. I wonder what en means. So anyway, so we'll do test output processor. So if pthread create and we give it a address to a thread type. Oh, output thread t is not supposed to be made into a pointer. Okay, and then pthread attributes. Don't know what to do for that yet. And start processor. And then the next is context, is like user data. We're going to store in global variables because we're only making one of these threads, so we don't really need it. And so adder, aggregate points per three attribute adder whose contents are used at thread creation time to determine attributes for the new thread. This structure is initialized using pthread adder init and related functions. If adder is null, then threads created with default attributes, which may be all we need. I wonder if I can get help on this. So, no, let's look for pthread adder. Pthread adder. Union pthread adder t, pthread adder t. I'm not sure if I'm going about this the right way, because this feels too hard. So pthread create and initialize using pthread adder init. Let's look up that. Let's look up that function. Adder init. Exclamation terms using sections, see attributes. Treat it as opaque. Any access to the other object in the pthread. Okay, so we have to pretend it doesn't have any fields. We can't access it. Display pthread adder. Get detached state. Pthread adder. Adder set affinity. We don't want that. Set detached state. I don't think we want that. Does it actually? So I have to actually go into all these sub pages to figure out what any of these fields mean, I guess. Set inherit schedule, set guard size, set stack size, stack address, pthread create, adder MP, set adder default MP. Yeah, I don't think we need to set any of these. So, okay. Let's wrap this. Okay. Don't actually need the square. Don't need the wrapper brackets. We'll just say die. No. Pthread create. 0 means no error. Or we do want error numbers, so we pass 1. Okay. Test output processor. Yeah. So we actually don't want to create it yet. We kind of want to create it up here. Int test output pipe. And then we do pipe test output pipe. And then the return value. Return value 0 is returned. On error negative 1 is returned, error no is set. Okay, so if pipe, then we also die. Pipe. And okay, let's see what else. We create the pipe, then we have to do fd open on each side of it. So the two followers referring to the ends of the pipe. Pipe fd refers to the read end. Okay, 0 is the read end. that means that we're going to do ft open open file descriptor and mode. Okay, so we do test output read test output pipe read equals ft open, and we give it test output pipe 0, and mode is read. Okay, and then we do test output. Then what else? We can also set this. Let's set this in the same spot, and we'll do fd open. Oh, we're going to need that. Let's save this. We're going to need it down here. In the function called void start output processor. Okay, and I believe it's supposed to return void. Let's finish reading this first. The return value, return a file pointer, otherwise no return error no is set to indicate. Okay, so I can do if not test output pipe read, then die 1 comma ft open. Maybe we want a a wrapper for FD open. Nah, I don't think so. It's so easy to just write this error check that I don't know if I really care about having a wrapper for FD open, at least not yet. So we have out an error equals FD open test output pipe 1 W, and then we if not out, then we die 1 comma FD open. Okay. Now what else? Then we start the thread, and I think that's all. Now man pthread create. It is attribute. So start routine has to return return a void pointer, which I'm not sure what it is. I guess it's like, can it just be null? Calling pthread exit with 5 spy in the return statement. Okay, pthread exit. Pthread exit. Can retval be null? I'm guessing it can. I'm betting it can. Should not be located on the calling thread stack. No. I don't see anything about if it can be null. But I'm gonna assume that it can be null. If not, then we'll look at it later. We'll debug it if we get a seg fault. Okay, so here we're going to read from the test output pipe. Oh, we want to do this. File output. So now we're going to go ahead and read from it. So I think we have util.h. We have these character reader functions which will not return error. And we'll go ahead and say, so we do xf close here. Yeah, I do want to make sure that I join with the thread when we're done. So anyway, int, so let's see, while 1, int byte equals xf get c, and we read from test output pipe read, and then if b is -1, then break, or we'll say return null. Let's do this. End of file. And also, otherwise, we do xf put c. Put c. We do have put c. Yes, xf put c, and we give it b and output. Oh, actually, we don't want to return yet. We want to break, and then we close the output stream, as well as close the test output pipe read. And xf close takes a pointer, I think, if I remember right. It takes a no. It actually takes the file itself. Oh, I don't like this. I want to fix this. I want xf close to actually set this to null. Set the stream to null, and I think I'm going to fix that because that's what I do elsewhere, I believe, or at least I did it in some other code base. Maybe I don't actually do it here. xf close. Grep xf close. How hard would it be to fix it now? Guess it's not that hard. Would it actually help me at all? Let's see, test. Let's edit. Because maybe I'm actually setting it to null manually, and I can stop doing that. xf close. Expected actual. Output. Read out. It seems like I usually, yeah, I'm not really needing it at this point. Maybe not. I'll just set it to test output pipe read equals null. Or maybe I could do this. I'll make a macro. xf close and null. And then we have a stream. And in this, we do xf close s, and then s equals null. And then, okay, well, we don't need that one. xf close and null. Null. There we go. And so, yes. But if b is 0, we'll do that. We'll do that later. We'll check that b is not 0. And then if it's 0, then we won't actually write it, because that is the only binary byte that we actually care about for now. All right. So start output processor, and then we have to go ahead and when we end the test, we need to cxf close, and then we close it, and then once we've closed it, then we can join. So pthread join, I guess. I think that's what's called. Yes, good. And return success. Red val is not null. Okay, red val can be null. Good, if we don't care about it. Pthread thread continuously is a return value. On success returns 0. On error it returns an error number. Well, that's annoying. So error no equals pthread join test processor. What was it called? Test output processor, and we give it null for that because we don't care. And if error no, then die 1. Okay. And then we can set this to null as well. Okay, now I'm probably not going to be able to build this because I don't link in the pthread thing. Assignment test output processor. Oh, this is not a pointer, so I can't really set it to null. Okay, that's fine. End of the void function. Okay, 72. I have to return null. And let's not parallelize it. Undefined reference. Oh, make J1. Undefined reference to pthread create and undefined reference to pthread join. Okay, so I need to link it properly. So pthreads threads link. I think it was like dash p. I think it was something simple like dash pthread link. Compile and link with dash pthread. Okay. Let's see here. C flags dash p thread. And link C flags. Am I already calling the linker with C flags? I think I am. Yes. Okay. So good. It worked. Now let's actually change test output somewhere and make sure that it can fail. Test output input test dot first. Test dot default view. Not that one. Keyboard. Let's see. Expected test out input test. I guess I could just change this one. There's no reason why not to. Okay, and this failed. Very good. Very good. Yes. They differ, and it's not telling me how they differ because it's a binary file, even though it's kind of not. All right. And this is ready, I believe. We're going to actually fix the null bytes in a separate commit. And start output process. I'm not sure if I want to take care of this fd open thing. xfd open. Let's just take care of the xfd open now. I'm somewhat worried that I'm going to just here xfd open file xfd open int d and char cons mode. Okay. We'll define this right after die, or no, we'll define it right after xf open. How's that? xfd open. Okay, let's see. F open. And then we'll do file f equals fd open, comma mode, right? And then if we don't have a f file, then we've got to die. Die, yes, fd open. Okay, otherwise return f. Okay. And then we use it, of course. Can't forget that. Okay, good. Okay, I guess we're done. So it was easy to change the make file to include pthread. That was good. And when we start the test, we start the thread. When we end the test, we end the thread. It's very simple. And we add a new wrapper for xfd open, and we also add a utility function which closes as well as nullifies some thing. But I don't know about this. This feels kind of half-assed. I maybe want to change xf close to actually change it. But you know what? I think that having this, the code is more self-documenting, because if I just do xf close and return a pointer, or have the caller pass a pointer to the file pointer, then it's going to be less obvious. But if I have this macro, it's actually pretty obvious what it's doing. And I think I have another end null thing here. Yeah, free. Oh, but I don't call it end null, unfortunately. I'll have to fix that eventually. Destroy array. xf close. So maybe we don't want to call it end null. We just want to call it xf close. xf close. Where do I call it? xf close. Okay. That's still working. Good. Now I think that I'm really ready to commit this time. Okay, so we'll say write actual test output in a separate thread. All right. Then we're going to make a new commit, which really is going to justify all the work we just did. So if b is 0, then we can continue. If b is in a file, then we break. Let's do this. If b is not equal to 0, then there. Okay. Or maybe a switch is better. Switch b. Case uf, then then I can't break out of the switch, unfortunately. Yeah, that's not good. Well, we'll break. Case 0 is continue, and default is write it. And then continue. And then we go ahead after the switch. Then we break. Yeah, but this just feels a little icky. How about int b? I mean, I don't like the fact that it's going to break in order to break down here, and it continues in order to go to the next one. That's just a little bit hard to follow. So what I'll do is I'll actually make this a proper condition. b is not equal to EOF. Okay, and then if b, then we write it. Oops, too many lines. So then we xf put c b comma output. And okay. Oh, that didn't work. If b, oh right. Because I already committed that. So here. So okay, good. So that's kind of what we wanted. Although now I'm sad that this is so different from the previous commit. So actually, maybe what I'll do is I will keep this, yank this, all right, and I'll kind of save that elsewhere. To new sort. I'm going to fix the previous commit so that it does this more intelligently. And then we go ahead and write actually test up a separate thread. Check out dot. Okay, so we will go ahead and use this. Okay, so that's what we'll actually use. And let me double check that it's still actually failing properly. Make, yes, it still can fail. Still capable of failure. Okay, now we're actually going to start fixing the test output. If B, then put it. Okay, make. And let's just do one at a time here. Okay, diff binary files. It thinks they're both binary files. I don't see how that's possible. Let's open one of them. We're going to open the actual output file and make sure there are no bytes. Test output diff. No, that's not what I meant. There. Okay, good. This does not look binary anymore. Binary. So this is kind of a bug in diff if it thinks that both of these are binary files. So let's copy this because we're going to use this new. Okay. Okay, so that test should now pass. Test input. Okay. First key is no longer failing. So now what I'll do is I'm going to make sure that the diffs actually work. So we go first key. First key. Where is first? We're going to open the file that we just changed. Let's go up, up, up. File. Now if we change it, then we should be able to get a real diff once we ask diff for a diff. Okay, good. So diff actually believes that they're not binary anymore. Now let's start again. Let's start doing this. Okay. Keyboard test. Okay, so basically what we're doing now is we're rewriting all these files without any binary, without actually any null bytes, so they don't appear binary anymore. Input test. CP. All right. CP. All right, good. So now we can get a diff binary files. Oh, it's not telling me what the new binary file is. So if I change a file from binary to non-binary, then diff is not going to help me, and neither will git's diff functionality. Okay. So now we can commit this, and we'll say remove binary bytes from expected test output files for easier diffing. And I will of course rewrite this and add more detail. So then there's a lot of stuff that I have to push and I have to rewrite into Japanese. Let's see. There was one thing I wanted to fix that's somewhat related. So there's this warning I learned about missing prototypes, which it will tell you if a function does not have a prototype for it. And I don't think we have this warning turned on right now. In other words, if you haven't, so this is important because if you have a header file where you declare a function, but then you in C you actually or in the .c file you create a function with a different signature, it's better to be warned about that right away, because that's something that could indicate that you don't know what the type of the function really should be. So let's say non-declared function. Let's see if this is an error. Make. See, there's no warning here, it looks like. So we will we're going to add the warning, turn it on, and it was error missing prototype. Let's copy this and missing prototype. All right. Now if we make, we get errors. Good. Oh, it's compiling twice? Just util.c. Okay. No, it's not. But it did. The function did have the problem does happen twice. So we will go ahead and we'll commit this. So I think I know it's so this function we created. We needed to make it static, but we didn't. So we will go ahead and commit this as enable missing prototypes warning. And I will fix the problem. Start output processor down here. This needs to be static. Okay, now it builds. So I'm going to combine that with this commit, which is where we actually introduced the non-static function that should have been static. Right, actually test output separate thread h3. Okay, get rebase I. And so now if we look at 3, this looks, we actually created static from the get-go. And okay, I think that's all for now. And this went pretty well. This was not more complicated than I thought it would be. Actually, it was a little bit simpler than I thought it would be. Yeah, so we did pretty good. We basically wrote code to debinarify the test output files, and this thread will probably get more complicated later when we start like writing colors. In other words, when we like colorize the output or colorize the kanji characters, because then we would like to test the colors as well. And so we may even like say sometimes we test the colors and sometimes we don't, and so maybe this function will will have some kind of parameterized behavior about whether or not it will remove the colors or not. And that sounds a little messy, but yeah, I'll make sure that I'll think it through before I actually start writing the code. Okay, and yeah, about colorizing the characters. So keyboard.c, like it's going to be hard to make the test output files pretty enough so that you can still read them, and also so that you can colorize the characters. And what will we use the colors for? So the colors would probably be for like indicating how common a character is. Or maybe the keyboard itself should not be colored, but some other information should be colored. So yeah, I'm not sure. I'm thinking about adding like a little guide up above here, which says like, hey, this is all the kanji characters with this sort key. And so let me just create some random junk. See, then this has that sort key, and then we'll show some more characters, which is like this. This is another sort key, and then below that we say, this is at key A, this is at key B, key D, K, C, L, something like that, and then this is at key J, Y, F, Z, and that way I don't have to search the entire keyboard for the character that I actually want. And perhaps these can be colored to indicate that and instead of using a space here to indicate that they're different sort keys, then we can actually just put them together and use colors to indicate that they're different. Or we can just put these all in a single line, like here, like D, K, C, L, and then the letters could be colored differently from the kanji characters. But this is actually not that great because this is going to take up a large amount of screen space. they're going to be up to 40 kanji, maybe actually 80 if we include shifted keys. There may be up to 80 kanji in a line, and so that means that this will be really long. 100, each kanji is two terminal cells wide, so 80 kanji means 160 terminal cells, which is more than what most people have it set to, more than what I have it set to, definitely. And actually, this is 240 or so. The right hand side is not quite 80. Actually, it's a little bit less than 80. Anyway, the yeah, I'll have to think about how I want this to look, because I think asking the user just to look at the keyboard is a little cumbersome. There's a lot to look at. So my other input system solved this problem somewhat by using colors to indicate the frequency of the character. So if the character was one of the, I think if it's like one of the Joyo kanji or the educational kanji, then it will use one color like yellow. Otherwise, it will use the default terminal color. In this settings, it's green. It will use the default terminal color if it's like not in any category. If it's like somewhere between Joyo kanji and these non-categorized characters, then it will be blue or something else, or maybe red. I think red is also used, or here, magenta. And so you know most of the time that you just want to find a yellow character. That's usually what you're going to do, is just look for the yellow one, because 99% of the time that's what you're actually typing. But it seems it may be a little bit more universal to have to use the sort key, because then I don't have to guess about how common the character is. Because sometimes I'm guessing, and I'm looking for yellow, but then I realize I don't want to look for yellow, and I was just looking for yellow so many times that it was just a force of habit. Anyway, so yeah, let's see. Did we commit everything? Yes. So that's all for this video, and thank you for watching.